Hi, if you're watching this video, this was an extra credit project assigned during the 12:30 p.m. statics lecture on Mondays, Wednesdays, and Fridays. I decided to build and do an analysis of a very basic and symmetrical 3D truss with popsicle sticks and 2 blocks of wood, using some washers and a bolt hanging from the top of the truss to act as a force on the structure. The weight of the hanging metal was approximately 0.286 pounds. After measuring the lengths of the different segments, I drew a free body diagram of the entire truss. Using these lengths, you can solve for the angle theta at the corners of the truss to be 45 degrees. From here, I did a two-dimensional analysis of the truss using the method of joints. I began by drawing a free body diagram at point A and summing up the forces in the x and y direction. Summing the moments around point C, you can solve for AY, which is 0.143 pounds. Using AY, you can go back to the sum of the forces in the y direction at point A to solve for FAD, which is 0.202 pounds. I then drew a free body diagram at point C and summed the forces in the x and y direction. Summing the moments about point A, you can solve for CY, which is also 0.143 pounds. Then using CY, you can solve for FEC and FBC using the sum of the forces in the x and y direction, which ends up being 0.202 pounds and 0.143 pounds. Summing the moments about point F allows you to find AX, which is 0 pounds, and going back to the sum of the forces in the x direction at point A, you can solve for FAB, which is 0.143 pounds. Following a similar pattern, I continued to draw free body diagrams of points B, F, and D. At point B, you can find that FEB is equal to FDB, and FBC is equal to FAB. Using the sum of the forces at point F, you can find that FFE is equal to FDF, which is 0.202 pounds. Finally, at point D, you are able to solve for FDB and FEB, which is found to be 0 pounds. I finished the analysis by drawing a picture of all the forces on the segments of my truss. However, since the actual truss is three-dimensional and the weight of the metal is acting in the middle of both sides of the truss, I chose to assume that the forces I found are equally distributed onto all the segments. So since there is actually 2 of each segment, each force I found is divided by 2. The final picture of all the forces of the segments is shown. Thank you for watching.